Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about the approaches to knowledge representation. These are the topics to be discussed, different approaches to knowledge representation as well as the properties of knowledge representation. This is the topic learning outcome for this particular topic. After the completion of this topic, students can discuss about various approaches to knowledge representation, including the semantic networks, frames, rules, and ontologies to improve human-AI interaction. Okay, before touching to this topic, let me discuss what I have discussed in the previous video. In my previous video, I have already discussed regarding the knowledge, intelligence, and reasoning, how the knowledge and intelligence are related to each other, and what are the different types of knowledge are there, and how the AI knowledge cycle works. That everything I have discussed. So today I'll discuss about the approaches to knowledge representation. So let me discuss what is the meaning of approach, because we know different techniques are there to represent the knowledge inside the knowledge base. So approach is nothing but the broad methodology or the paradigm, we can say, which is used to structure and represent knowledge in artificial intelligence. So in a broader sense, we can say what is the structure of the representation of knowledge, that is called as approach. And if we take the example of, or if we choose any technique that comes under inside the approach, and this approach defines the overall way in which the knowledge is structured and used. That is the overall representation of the knowledge, as I told. So it is also a conceptual framework for the knowledge representation. It helps in selecting the best way to represent the knowledge for a given AI system. So overall, I hope you might have understood what is the meaning of approach and how it is different from techniques. In broader sense, the structure of knowledge is called as the approach. But inside the approach, if we can use different techniques to represent the knowledge inside the using for different knowledge representation. So these are the various approaches to knowledge representation. Basically, there are 4 approaches to knowledge representation which are given below here. The first one is simple relational knowledge. Second one is inheritable knowledge. Third one is inferential knowledge. And the fourth one is procedural knowledge. So it's very easy to easy words are used here. I hope you all can understand what is the meaning of simple relational knowledge, inheritable knowledge, and inferential knowledge, as well as the procedural knowledge. One by one, I'll discuss. So the first one is simple relational knowledge. So first of all, this type of approach is very simple. That is why it is called as simple and relational, where some relation exists for the representation of knowledge. That is why it is called as simple relational knowledge. It is a straightforward method for storing facts using the relational structure. I hope you might have known where this type of structure we used to use, especially it is used in the database system, because in database we used to store the related data in the form of rows and column, that means in the form of table, so that retrieval of data or updation of data, it would be easy for us. And it is that is why it is called as It is a straightforward method for storing the facts using the relational structure, where the information about the object is organized systematically in a tabular format. Tabular format means like in the form of rows and column. On the top, we will write all the attributes, and under the attributes, we can store all the domain of the attributes, and we can define how all the attributes are related to each other. Even we can identify what is the relation between different entities. Like for example, if you take the example of the college, like faculty is one entity, student is an entity, principal is an entity, head of the department is also an entity. We can create the table for all the entities, and we can find and we can establish the relationship among all. Even we can establish the relationship between the attributes of a particular entity also. Like for example, if we take the example of the student entity, inside the student entity we can write the student roll number, student name, what are the marks they secure in the previous semesters, and we can find what is the relation, means relation between all the attributes, like relation between the roll number and name and the marks. So using that we can retrieve the record from the relational table. So that is why in simple relational knowledge we can store the knowledge in the form of tabular format, that means in the form of rows and column. So this model basically it is widely used in database system as it efficiently captures the relationship between different entities. Just now I discussed how different relationship between entities can be maintained. While this approach is effective for data storage and retrieval, first of all, in a tabular format, if we store the data in the form of table, storing of data, it would be very easy. Even accessing of the data from the table or the retrieval of the data from the table, it would be very easy. But the problem is it provides minimal opportunities for logical inference and or reasoning. We cannot retrieve the logical inference, or we cannot derive any conclusion for a particular entity. It would be very difficult for the representation of relational structure. So that is why we will go for some other structure which is called as inheritable knowledge. So, but before the invention of this relational knowledge, first the knowledge was represented in the form of file, where the knowledge are written in the form of paragraph, and it is also very difficult if we represent the knowledge in the form of paragraph like a document. Again, it would be difficult to retrieve the knowledge from the file system. That is why the relational knowledge came into the picture, where the knowledge can be stored in the form of tabular format. Though it is very easy to store the data, but we cannot find or we cannot derive any conclusion from the table. That is the main problem with the simple relational knowledge. This is one of the examples for the relational knowledge. Here we are considering a student database, or we can consider as student as an entity for storing the student details and their enrolled courses using relational knowledge representation. Now in this table here I have represented 4 attributes. One is the student ID, second one is the name, third one is the course, and fourth one is the grade. These are the attributes of this student entity, and whatever the values we have stored inside the student ID like 101, 102, 103, these are the domain of student ID. Same thing, the names, all the 3 names are the domain of name attribute. All the 3 courses, AI, database and AI, all these 2 courses, but AI is repeated anyways, but these are the domain of the attribute course. Same thing, the grades are also the domain of this attribute grade. Now attribute student ID, name, course and grade, and each row like the first row, because 3 rows are there except the attribute row, the first row which is called as the attribute row. So these rows are called as the record, or else it is called as the tuple. In database, normally we used to use these words. Either it is called as the record or it is also called as the tuple. So here each row represents the fact. Represents the fact means like I want to access the information about the student ID 101. So 101 means the person is alive, and course he has enrolled for AI, and grade he has scored A grade. So that is the information about the roll number or the student ID 101. So each row, that is why each row represents the fact about a student and their course. The relationship, how the relationship is maintained, the relationships, for example, which student are enrolled for AI, okay, are explicitly stored inside the table. Like 101 student has enrolled for AI course, even 103 student has also enrolled for the AI courses. So 2 students have enrolled for AI course. So that is the relationship. But as I told, the problem is the inference mechanism. We can retrieve, suppose you want to retrieve the information about the student ID too, we can retrieve using queries. But the problem is we cannot derive any conclusion for the whole table. That is called as the inference is limited. For example, the table does not automatically determine which course is most popular, but it is visible for us because only 3 rows are there. AI is most popular because 2 students have enrolled. But this type of inference from a particular entity, it is difficult for the relational model or relational representation of knowledge or relational approach, we can say. So that is why to overcome this problem, we'll go for the next approach, which is called as the inheritable knowledge. The word inheritable means something which inherits. So that is why here the concept of inheritance comes into the picture. So this approach structures all the data in a hierarchy of classes. One after the other, the class, subclass, their objects, their attributes, everything will be stored in the form of hierarchical format, where each class is arranged in a generalized or hierarchical manner. Here, objects in the hierarchy inherits the properties from their parent classes, which establishing the relationship between the instances and classes, which is known as instance relation. I'll explain what is the meaning of instance relation is maintained in the hierarchical knowledge approach. Now you can see this image. This image represents the hierarchical structure. The first square box where it is written as adult male. So this is with this one we can say the generic class. This one we can say generic class, or we can say super class. This one we can say generic class, or it is also called as the super class. After this, the player class is there. This is also another class. This is called as the subclass. That means every player, what it says, every player is an adult male. Okay, every player is an adult male, where adult male is the super class, or else it is called as the generic class. Now again, this player, the subclass, is divided into 2 parts. One is the cricket, another one is the football. That means the person who plays cricket is also a player, as well as the person who plays football is also a player. Okay, now 2 examples are given. So examples are nothing but the instances. The last one, Peter and Ankit. Okay, so these 2 are the examples of the player who plays cricket, and Ankit is a player who plays football, and Peter is a player as well as Ankit is also a player. So here what happens, at the top level, the superclass is maintained. Then the next level, subclass is there. Now subclass, the player is an adult male. That means every player is an adult male. And the relationship between these 2, this player and adult male, is A. So is A, it is a relationship, especially it is used for inheritance. So that means the subclass can inherit the properties of the superclass, right? Now again, at the next level, the player is divided into 2 parts, cricket and football. The player who plays cricket is a player, and the person who played football also is a player. So what is the relationship between the cricket and player? Is A. Here also football and player is A. So that is also a concept of inheritance. So these 2 players, that means it is these two cricket and football also inherits the properties of the player, as well as they inherit the properties of the adult male also. Now, at the lowest level, 2 examples, as I told, it is given. One is Peter and Ankit. Peter is an instance of cricket and Ankit is an instance of football. That means Peter is a player who plays cricket. Ankit is also a player who plays football. So what is the relationship between Peter and cricket? Instance, because it is an example of the cricket player and Ankit is an instance of the football player. So that is why the relationship is called as instance. Basically, in hierarchy or in our hierarchical structure, inheritable structure, is a type of relationship. Instance is also a relationship. So that is why in the previous slide I told it is called as instance relation. Instance relation between the example and the subclass or the superclass. So the main goal of this particular intention of this particular example is how the subclass inherit all the properties of the parent class, and how the examples also inherits all the properties from their parent class. So is a relationship, instance is also a relation. So this is the way the class, subclass and superclass are maintained in a hierarchical format to represent the knowledge. The third one is inferential knowledge. Infer, something we can derive. That is the meaning of inferential knowledge approach. So inferential knowledge is a knowledge representation approach which allows us to the system to derive new facts from the existing knowledge using inference rules. So many inference rules we know. For example, if I say I'll write P implies Q. So that implies I can write negation. I can write negation of P and Q. That means negation of P and Q we are deriving from the existing knowledge or from the premise P implies Q. If P and Q are two propositions, then if P implies Q, that means if key P then Q, that implies we can derive this one negation of P or Q. So that is called as whatever we are deriving from the existing knowledge, that is called as the inference. Using what? Using the inference mechanism or using the inference rule or the logical rule. So that type of approach is called as inferential knowledge. So knowledge approach. Inferential knowledge, it is a knowledge representation approach that allows the system to derive new facts from the existing knowledge using inference rules. Now inferential knowledge allows the AI system to think and reason rather than just storing the fact. Like in our relational knowledge, we used to store the facts, but it cannot, if you apply to think about for the relational knowledge approach, it cannot think or it cannot reason. But inferential knowledge approach can think, even it can understand, try to reason to derive any valid conclusion. So that is why it can think and reason rather than just storing the facts. This approach normally it is used in the expert systems, AI reasoning models and decision support systems. So all these systems are AI systems, I can say. Expert systems, the systems which can give the expert advice to the user based upon the knowledge, whatever it is stored inside the expert system. AI reasoning model, which has the capability to reason and think to derive valid conclusion. And decision support system, normally in big organizations, they used to use this type of automated AI system to take big decisions, especially for the high level managers. So that is why it is called as the decision support system. It helps to take the decision. And unlike the relational knowledge, this approach enables automated problem solving through the logical rule. As this knowledge approach is having the capability, like it can think and reason, and it can derive some valid conclusion using some logical rules. That is why it is used for automated problem solving. Automatically it can solve the problem by applying some inference mechanisms or inference rules or logical rules. This is one of the examples for this inferential knowledge approach. We'll take here the scenario is AI-based smart home system. Now, a smart home assistant makes decisions based upon a set of rules and facts to improve the energy efficiency. Now, we'll see about what actually smart home assistant, it is an automated system. Now, based upon the rules and facts, how it will derive the conclusion. That is what I want to explain here. Suppose the rules which are already declared for the knowledge base are like the first rule is, if the outside temperature is above 30 degree and the house is occupied, that means somebody is there inside the house, then turn on the air conditioner. That is the rule 1. Rule 2 is, if the room temperature is below 18 degree, then turn on the heater. And third rule is, if no one is at home, then turn off all the appliances to save the energy. So based upon the 3 rules, these are the rules which are declared inside the knowledge base. Now we'll see some facts, like the right now, what is the condition at the right moment, outside what is the condition, and what this inference mechanism will do, it reason or it will apply the mechanism, inference mechanism by using some logical rules for these rules as well as facts, then it can derive the conclusion or it can derive the inference. Now the given facts are for the same AI-based smart home system. The facts like the outside temperature, right now the outside temperature is 32 degree and the house is occupied. That means somebody is there inside the home. Then given facts, these are two facts, three rules I told. Based upon these rules and facts, now the system, AI-based smart home system can derive this inference. What would be the inference? As per the rule 1, you can see the rule 1. If the outside temperature is above 30 degree and the house is occupied, then turn on AC. The same thing, I think the fact it matches with the rule 1. Outside temperature is 32 degree, which is above 30, and the house is occupied. So what inference it will derive or what conclusion will come out based upon the rule 1? Since the temperature is above 30 degree and someone is inside home, so the system turns on the air conditioner. So that is the conclusion, or that is the derivation from the rules and facts. So this is the way the inference knowledge approach works. Now the last one is procedural knowledge. So procedural knowledge approach, which uses, as the name it implies, it follows some procedure, it follows some rules to solve any specific problem. So it uses small programs and codes which describes how to do a specific thing and how to proceed. So in this approach, one important rule which is used as if-then rule. If the condition, like if the number is divisible by 2, then it is an even number. If the number is not divisible by 2, then it is not an even number. That is an odd number. So like that code, if-then rule is used. So in this knowledge, we can use various coding languages as it follows some procedure like Lisp language, LISP, which stands for list programming, as well as the Prolog language also. Especially for AI, these are the famous languages. Even we can use the Python language also. So we can easily represent the heuristic or domain specific knowledge using this approach. Domain specific means the knowledge which is related to a particular area or the existing knowledge which are required to derive some conclusion. Those knowledge can be represented using procedural in the form of language or small program or codes. Now we can see one, but it is not necessary that we can represent all cases in this approach. This approach is not suitable for all the cases. Procedural approach is about how to do things rather than just knowing the facts. It is widely used, same like the previous one. It is also used in the expert systems, robotics, automation, and any AI applications. Unlike the inferential knowledge, which derives the conclusion, this procedural knowledge, it performs the action. Because we are writing the code, it will solve the problem. So that is why it is called as it performs action. Not only derives the conclusion, it also performs the action. You can see the example here, like to prepare a dish or cooking a dish, like it is like a human expertise example. Like a recipe is an example of procedural knowledge. This is a real life example. I can say, like before writing any particular code in any language, we used to write the algorithm, or like the step-by-step algorithm we used to write. The same thing, to prepare a recipe, we used to write the procedure. Like step 1, it may be the gathering the ingredients like the flour, eggs, sugar, and butter. Step 2, mix all the ingredients. Step 3, preheat the oven to 180 degrees centigrade, and step 4, bake for 30 minutes. Then our cake will be ready. So the knowledge of how to bake a cake is a procedural because it involves a sequence of steps. So these are the steps we use. Normally anybody can say how to prepare a cake. So this is this type of procedure we used to follow. Similar kind of procedures are used to write the program also. Now let me discuss about few properties of the knowledge representation system. So any good representation system must possess following properties. The first one is the representational accuracy. Representational accuracy means accuracy. The word comes from the accurate. Representational, which can be represented inside the knowledge base. So that is why the first property is called as representational accuracy. So knowledge representation system should have the ability to represent all kinds of required knowledge. It's not like the knowledge representation system will represent whatever we are telling, it will be represented inside the knowledge base. It should have the capability to represent what are the knowledge are required for that particular domain. That knowledge will be represented. So it should have the capability, or it should have the ability to represent. Second one is inferential adequacy. Inferential adequacy means the knowledge representation system should have the ability to manipulate the representational structure to produce new knowledge corresponding to existing structure. That means every knowledge representation system should have the capability of inferencing or deriving some new knowledge from the existing knowledge. That is the, like how we have some qualities, same thing, every knowledge representation system should have the capability of representing the knowledge accurately, that to required knowledge. It should have the capability to manipulate the knowledge as well as to derive the conclusion from the existing knowledge. And the third one is inferential efficiency. That means the ability to direct the inferential knowledge mechanism into the most productive directions by storing appropriate guide. And the fourth one, acquisitional efficiency, means the ability to acquire the new knowledge easily using the automatic method. Automatically, the knowledge can be acquired. Automatically, the knowledge, the system can derive conclusion. Automatically, the knowledge will be represented as much as required. And automatically, it can infer, like inferential efficiency should have the efficiency to infer the knowledge. So all these four properties are automatic, we can say. It should be there for any knowledge representation system to represent the knowledge efficiently and effectively. So this is all about this video, as I have discussed different approaches of knowledge representation as well as the properties of knowledge representation system. For the preparation of this video, I have followed especially the Soros book for artificial intelligence. I have followed this YouTube channel, also even Edureka website. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.